Do you hear all that noise? It's because there's three people teaching in this house at this moment as I'm recording this. Groundwater. Yep, more water. That's all right. Groundwater is really important though. If you live in Southern California, much if not all of the water you get that you drink is coming from groundwater, unless you live in South Orange County where that's overwhelmingly coming from the Colorado River. So it's an important thing. It's an important resource. It's something you don't want to pollute. It's something that we want to take care of and recharge as much as we can possibly do that because let's face it, we can live without oil. We cannot live without water. When precipitation falls to the ground, in whatever form it falls, it will either flow across the surface as runoff, or it's going to soak into the ground as groundwater. Good name for it. Groundwater is the subsurface waters of the earth, which have entered primarily through precipitation that has percolated downwards. You know, percolate is like what happens with coffee, right? You have this hot water, it goes down through the coffee grounds, and then into the pot comes the coffee. So it percolates down through that. The same thing is going to happen with water, that it percolates down through the surface of the planet. Look at this diagram. You can see there are three things written on this diagram: the zone of aeration, the zone of saturation, and the water table. The zone of aeration is the subsurface area in which all of the available pores and spaces are not filled with water. So there might be some water in it, but there's still places to put water. The zone of saturation is the subsurface area in which all of the available pores and spaces are indeed filled with water. In other words, it's saturated. When people talk about groundwater, almost nobody, unless they're in the business I'm in, talks about the zone of aeration and the zone of saturation. People always talk about the water table. Well, the water table is the upper level of the zone of saturation. This fluctuates throughout the year. During the wet season, the water table will rise. In other words, the zone of saturation will expand and the zone of aeration will be compressed. And during the dry season, typically, the water table will go down, which will shrink the zone of saturation and expand the zone of aeration. It's just a matter of infiltration of water or people drawing water out. Subsurface rock or subsurface materials, the structure underneath the ground, helps determine the ability of water to be able to be held as groundwater. We can classify the subsurface areas in one of two ways. Either as aquifers, this would be a layer of rock or other material that allows water to infiltrate it and pass through it, or aquicludes. Just think of the word preclude, okay, how this goes together. This is a layer of rock or other material that does not allow water to infiltrate and pass through it. Let's look at this diagram. The blue arrows are pointing out aquifers and zones of saturation. These, in the case of this diagram, are on the top sandstone, which is an excellent aquifer, and limestone, which is another excellent aquifer. Now you can see that the, what color? Bronze, is that what we want to call this? Arrows are pointing at aquicludes. And those aquicludes in this case are in the top layer, clay, the bottom layer, shale. Okay, they do not allow water to pass through them, especially if it's dense clay. A spring is formed when the water table intersects the surface, as you can see pointed out with the purple arrows. So you can see it says perched water table over on the right-hand side in that zone of aeration, sandstone, that whole area there, and the blue is representing the zone of saturation. But then you can see that the water table intersects the ground just above that impermeable bed of clay, the aquiclude, and that allows water to flow onto the surface. That's how a spring is formed. Artesian wells are formed when water flows to the surface under its own pressure. That reddish, rusty colored arrow is pointing at the zone of aeration. The blue arrow is pointing at the water table, which is the top of the zone of saturation. The purple arrow is pointing at a hole that someone has dug in the ground, a well. This is where the artesian well is going to form. Notice that that well has been dug down into the zone of saturation, which is represented by that kind of darker blue color. Below the surface, water flows downslope just like it does above the surface. So you can see that what's happening is that water is flowing downwards underneath the ground. The groundwater is flowing downwards. And then when it hits that well, under its own pressure, it's able to flow to the surface. The red line I just put on there, that is the level of the water table. And as long as that well is below the level of the water table at its highest point on this landscape, that water will, under its own pressure, flow upwards.